Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lufi Hanif bin Marzuki. My matric number 1910933362. Okay, today I would like to present about nuclear power generation. Okay, in nuclear power generation, and I will tell you about introduction. In introduction, I will tell you about type of power generation, and the second one is how nuclear power plant work, and the third one is background study. Okay, the first one, for the first slide is I would like to tell you about the introduction. Okay, uh, in this study regard nuclear power generation encompassing various type of definition, such as introduction nuclear power generation. Okay, nuclear fission occur when a free neutron collide with the nucleus of fissile substance such as 235U in the production nuclear power. When the nuclear collide, it separate into significant fission piece, such a radioactive krypton and cesium, and two to five additional additional free neutron, sorry, releasing energy in the form heat. During the process, some of the new released neutron collide with the other fissile nuclear, causing them to split and a chain reaction to occur. A reactor or a pile is a facility contain fissile material. Heat is a generator, the reactor, which must be transformed into generator using heat turbine and generator. Okay, for the next slide, I would like to tell you about a type of nuclear power generation reactor. Okay, there is two types. The first one is pressurized water reactor. Okay, this is a schematic diagram for pressurized water reactor, PWR. Okay, for pressurized water reactor is a power reactor which heat is transmitted from the core to the heat exchange by high temperature water in the primary circuit does not boil. Heat energy is transported to the second water system which produce steam, and the steam is then used to power turbine generator which generate electricity. The system is made up of pressure vessel contain nuclear fuel that create heat energy, a steam generator that convert the heat energy into steam, a circulation pump, the circulate coolant, and the pressure system that maintain and manage system pressure. Okay, for the next slide, I would like to present about boiling water reactor, BWR. Okay, for this slide, this is the schematic diagram for boiling water reactor. Okay, for the explanation about boiling water reactor is the boiling water reactor is direct cycle steam producing technology is which reactor coolant boil in the core and generate steam travel directly to a turbine through moisturized spirator and steam dryer. The steam is condensed after going through a sufficient heat cycle. The condensed is pumped from the condenser through full flow polishing and full flow polishing, demineralized and feed water heater, and the final back to the reactor. Okay, the next one I will tell you about the background study, like history about nuclear power generation. Okay, nuclear power was initially proposed in 1930 when physicist Enrico Fermi demonstrated that neutron could break atom. In 1942, Fermi had a team that created the first nuclear chain reaction, which took place beneath at stadium at the University of Chicago. The first electricity generated from atomic energy was created in Idaho Idaho Experimental Breeder Reactor in 1951, followed by the first nuclear power plant in former Soviet Union, Obninsk in 1954, and the first commercial nuclear power plant in Shippingport, Pennsylvania in 1957. Okay, that's all for me, and I will pass the next slide for my group member to continue this presentation. Thank you.
Assalamualaikum, my name is Muhammad bin Kamarul Azad, metric number 1910922326. In theory part, there are two types of general reactors: pressured water reactor, boiling water reactor. Pressured water reactor. At first part, reactor vessel will go to steam generator, and then from the steam generator will go to high pressure turbine to create electrical energy, and it will go to miniaturized separator. At miniaturized separator, it will separate oil, gas, and water. After separated the item, water will go to preheater and then go to low pressure turbine to generate electrical energy, and then water will go to condenser and go to condenser pump. After that, feed water heater, and then it will go back to steam generator. In this part, heat exchanger, and then uh, the water go to reactor coolant pump, and pressured water reactor coolant will go to reactor vessel. In next slide, boiling water reactor. Reactor will go to steam turbine, which is high pressure turbine, and what and water will go to miniaturized separator, and then it will go to low pressure turbine to create electrical energy and go to condenser. After that, the water will go to condensate storage tank and also go to feed water heater, and then water go to mineralizes and back to recirculation pump. That's all. Thank you.
Assalamualaikum. My name is Muhammad Khairul Amin bin Aizan. My matrix number 1910923333. Okay, for our group that get the title that is Nuclear Power Generation, I will present to you about mathematical model. Nuclear energy is the energy that is trapped inside each atom. Matter can be changed into energy. Albert Einstein famous mathematical formula, which is E equal to mc square, which mean E is energy, m is mass, and c is the speed or velocity of light. Okay, in the nuclear radiation, there has two, nuclear fission and fusion. For the first one, we can see is uranium, and then krypton, sunlight, and juga boron. Energy can be obtained two ways, which mean fission and fusion. Okay, for the fission, we'll be splitting the atom. Get energy if the nucleus is big, the smaller one are more stable. Nuclear reactor, which mean is the nuclear power plant. Okay, for the fusion, we'll be joining atom together, get energy. If the nucleus are energy, the large one is more stable. This is how the science works. Okay, for the nuclear fission, fission is the splitting of atom. They are usually very large and not as stable. fission chain has a three-step, which mean initiation, propagation, and also termination. A very heavy nucleus splits into more stable nuclei of intermediate mass. The mass of the product is less than the mass of the reactants. Missing mass is converted to energy. Okay, in the nuclear fission, a large nucleus is bombarded with a small particle. The nucleus split into smaller nuclei and several neutrons. Large amount of energy are released. Okay, this is the nuclear fission diagram. As we can see, this is a uranium neutron, and then uranium become unstable, and then will be happen krypton, sun, and also boron. This is the equation of how the nuclear fission happen. Okay, this is chain reaction. A chain reaction occur when a critical mass of uranium undergoes fission and also releasing a large amount of heat and energy that produce an atomic explosion. As we can see, the first one will be spread. Okay, this is nuclear power plants. In nuclear power plants, fission is used to produce energy and also control roles in the reactor absorb neutron to slow and control the chain reaction of fission. Okay, this is how the nuclear power plants works, as we can see in the pictures. Okay, for the fusion, light mass nuclei combine to form a heavier, more stable nucleus, more energetic than fission reaction. Source to energy for the H bomb, H which mean hydrogen, and origin of the element. Okay, as we can see the picture here, hydrogen bomb 100,000 times more powerful than atom bombs. For the nuclear fission occur at extremely high temperature, 100 million Celsius, will be combined small nuclei into large nuclei, will release large amounts of energy, and occur continuously in the sun and the stars. As we can see, this is the picture and this equation. Hydrogen will become helium, neutron, and energy. For the fission, small nuclei form large nuclide will release energy. Okay, this is the equation. From the deuterium, tritium will become one, and also will produce energy, neutron, and also helium. This is a type of fusion is being examined as an alternative energy source on Earth. Okay, this is capacity factor by energy source in 2020. As we can see here, the nuclear is the highest as 92.5% compared to others energy source, geothermal, natural gas, hydropower, coal, wind, and also solar. Okay, how many of the population got access to the electricity produced? Okay, one reactor equal to 1 gigawatt is roughly the size of 2 coal-fired power plants and is enough energy to power 7,500 homes. Okay, this is the picture, electricity generation, transmission and distribution, how the nuclear power plant will generate electricity. Okay, then go to the transformer to step up for transmission, and then transmission line will carry the electricity in a long distance, and also to go to the transformer to step down the voltage, and also to the distribution for the houses. That's all from me. So thank you very much for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hasib bin Syarudin. My metric number is 1910923330. For my part, I going to present percentage of the type of power generation in the energy mix. So around the world, nuclear have been supplied 10% of overall world electricity. So from here we can see this is a pie chart based on energy mix based on 2020. We can see nuclear have been supplied to 10.1% of overall energy mix. So this is a bar chart based on Europe. We can see the electricity production. This is sourced from World Nuclear Association. Are there any government's commitment towards property a sustainable and cleaner production of the type of the power generation? So in the South Asia, using nuclear technology for peaceful purpose initially began in the Cold War. So USA assists South Asian country in constructing 3 RIGA class nuclear research reactor focusing on the medical and the research purpose in Indonesia, Philippines, Vietnam, Malaysia, and Thailand. So this is a 10 country, Asian 10 countries, Southeast Asia. This is the country that have been involved. For Malaysia, Malaysia have been established an agency which is Malaysia Nuclear Agency (MNA) that has operated the Puspati TRAGA research reactor. So later on, set up the Atomic Energy Licensing Board with under the supervision of Ministry of Science. So Malaysia initially planned to implement commercial nuclear power by early 2020, but Fukushima nuclear disaster caused the plan is deferred to deadline. So in 2018, Prime Minister has been said, if you have a nuclear power plant, you will be accumulate nuclear waste, which is radioactive, and until now, they do not know how to reverse the process. We don't want this country to be full of such waste thrown over the place and affecting people. Tun Dr. Mahathir. Okay, compare three of power generation already existing in the South Asian. So currently there are no nuclear power station that operating commercially electricity in Southeast Asian country. So this is South Asian nuclear weapon free zone. However, pro-nuclear comes up with many reasons aiming to neutralize the nuclear power, which is ranging from growing of the domestic power demand to the boost economic activity, reducing the electricity cost. Currently, there are three types major of power generation that used in Southeast Asian. Also, remain primarily global energy source, which is coal, oil, and gas. So these three is known as fossil fuels from over millions of years ago, as a dead plants and animal were subjected to extreme heat and pressure in the Earth's crust. This nature process convert bones and other organic matter into a carbon-rich substances that, when burned, and generate energy. There are three main fossil fuels, which is petroleum. We can see petroleum and oil are often used interchangeably. It's extracted through a drilling or hydraulic fracturing, also known as a fracking, which is fracking is a proven drilling technology that used for extracting oil, natural gas, and geothermal energy or water from a deep underground. So for the second one is coal. We using machine and miners to remove coal deep down underground. The third one is natural gas, which is a mixture of the gas trapped underneath the Earth's surface. It's an extract similar a way as a oil, like fracking. We're using fracking process. So advanced in the drilling and the fracking has been unlocked vast reserves of the natural gas. That's all from me. Thank you very much.
Assalamualaikum warahmatullah. My name is Muhammad Najmi bin Abdul Hamid. My matrix number is 19109340, and I will discuss regarding the advantage and disadvantage of nuclear power generation for the discussion section. We will start for the first advantage. The first advantage for the nuclear power generation is low cost of operation. So we see nuclear energy has the benefit of being one of the most cost-effective energy alternative accessible after the initial building cost, unless such resources are situated near the power plant they feed. The cost of producing electricity from nuclear energy is substantially cheaper than the cost of producing electricity from gas, coal, and oil. Nuclear energy also offers the advantage of having a minimal risk of cost inflation as opposed to traditional fossil fuels, which are subject to price fluctuation on a regular basis. For the second advantage is reliable source of energy. While certain energy resources such as solar and wind power are subject to weather condition, nuclear energy is not. It makes no difference if there is no wind or if the day is overcast. External climatic influences have a little effect on nuclear power facilities, which produce predictable and consistent energy production. For the third of the advantage of the nuclear power generation is the produces low pollution. Compared to energy generation from fossil fuels, the overall pollutant output from a nuclear power station is fairly modest. Nuclear energy usage now decreases annual emission by more than 555 million metric tons. This reduction in greenhouse gas emission is an excellent example of how switching to a nuclear energy may help us lessen our long-term impact on global climate change. Okay, for the fourth one of the advantage of using this nuclear power generations, it has high energy density. Nuclear fission, which is the process for producing nuclear energy, produces far more energy than just fossil fuels such as gas, oil, and coal. So nuclear fission is almost 8,000 times more efficient than traditional fossil fuels in producing energy. Okay. I will continue for the disadvantage of using nuclear power generation. For the first disadvantage of nuclear power generation is it is water intensive. Using too much water to generate electricity. Nuclear power plant need a lot of water. The United States used about 320 billion gallons of water in 2015, if I wasn't mistaken, to generate nuclear electricity. That's more water than is utilized in the coal processing process. This massive water usage might become unsustainable when water become increasingly scarce. When we are in a shortage of water. especially in the face of climate change. For the second one is the disadvantage is risk of nuclear accidents. Nuclear power station are like subject to stringent safety regulation. Accident do happen regardless how cautious you are. We know from occurrences like the Fukushima tragedy, the Chernobyl, and the 3 Mile Island in Pennsylvania that a nuclear plant meltdown may have a disastrous consequences for the surrounding areas. In the case of a nuclear meltdown, dangerous radiation might flow, posing a risk to the environment and human health as a result of it. So the third one is radioactive wave. Radioactive waste is a disadvantage of using nuclear power. It does release the nuclear power does not release damaging greenhouse gases into atmosphere, but it produces hazardous waste. For the last one of the disadvantage is the last disadvantage of using nuclear power generation is it is a non-renewable energy. Once it is used, the source will be limited due to the fact that the uranium, the fuel used in the nuclear reactor, is a limited resource. So we are depleting the quantity of uranium accessible as we mine it, and no more will be generated within a human lifetime. That's all from me. We meet again, inshallah. Assalamualaikum warahmatullah.
Okay, thank you, my friend, for your presentation. Okay, I would like to continue this presentation about conclusion. Okay, in my conclusion, I will tell you what we get in this experiment. In this experiment and this research for nuclear power plant, nuclear power generation. Okay, for the conclusion, why nuclear power will not be able to completely replace fossil as a source of sustained energy. It can help to reduce the carbon footprint of electricity generation. Nuclear power should be explored as a viable carbon-free energy option to address future issue of climate change and other environment concerns. Despite several hurdles that are limiting and changes for continued growth. Today, worldwide challenge is device way that promote a less reliant of fossil fuel energy future. Nuclear power may be essential contribution to sustainable development as a proven and ecological benign technology with the ability to provide long-term energy supply in the future. It is a versatile power source that provides base load energy and has wide variety of possible non-electricity application. We hope that nuclear power will be adapt in more flexible, reliable, and efficient source of energy in the upcoming future. Okay, that's all for me. For conclusion, thank you.